Welcome to the Cabinet of Science and Fiction.
It's great to be diving into this one.
Absolutely. Get ready, because today we're looking at some ideas that might just, well, flip some fundamental rules you thought govern the universe completely on their head. We're diving into the really intriguing and, often debated realm of free energy.
Specifically focusing on the work of Nikola Tesla and Edwin Gray. Groundbreaking, definitely controversial.
Exactly. Think possibilities that, could potentially rewrite physics as we understand it.
Right. We're going to explore how their research, Tesla's and Gray's, hinted at energy sources and behaviors that seem to go way beyond our current scientific models.
Particularly these concepts they called cold electricity and radiant energy.
Yeah, these aren't exactly mainstream textbook terms, are they? But they offer this fascinating glimpse into what might be possible, even if it challenges convention.
And our goal here isn't to get totally bogged down in super complex technical details or to definitively say this guy was right, that theory is wrong.
No, not at all. It's more about unpacking the really mind-bending parts of their experiments, their theories, especially the ones that seem to, sidestep the traditional laws of thermodynamics.
We want to pull out those core insights, those moments that make you go, what if, those things that really make you think.
Hopefully leaving you with a few genuine aha moments along the way.
So where should we kick off this electrifying exploration? Maybe with Gray. His story seems particularly perplexing.
I think that's a great starting point. Edwin Gray, born back in 1923, he really stirred things up in the early 1970s. There was a lot of buzz around his idea of what he termed cold electricity.
Cold electricity. It just sounds contradictory, doesn't it? What was so weird about it? What did people actually see?
Well, there are accounts. Probably the most detailed comes from a reporter at the National Tatler, of all places, who supposedly witnessed some really remarkable demonstrations at Gray's lab out in California.
Okay, like what?
In one demo, a standard 6-volt car battery, nothing special, was apparently powering multiple 15-watt light bulbs, a 110-volt television, and 2 radios, all at the same time.
From a single car battery. That sounds like a lot of draw.
It is. And the really strange part, the battery reportedly showed no significant drain afterward. I mean, that little battery just shouldn't have been able to sustain that kind of power output under normal electrical principles.
Right. So the key takeaway there is this huge mismatch, this disproportionate energy output compared to what was seemingly going in.
Exactly. That alone is enough to make you raise an eyebrow, right?
Definitely. But wasn't there another demonstration, something involving water, that was even stranger?
Ah, yes. That one was maybe even more astonishing. In another setup, Gray powered a 40-watt light bulb using his device. Standard enough.
Yeah.
But then he apparently dropped the lit bulb right into a tank full of water.
Whoa, okay. Sparks flying? Circuit breakers tripping?
Apparently not. The reporter described how Gray then calmly put his hand into the water right next to the still glowing bulb and felt absolutely no electric shock. Zero. Richard Hackenberger, who was an engineering VP with Gray's company at the time, was supposedly there and called it a new manifestation of electricity.
Okay, that's wild. A live bulb in water, someone touching it, and no shock. That defies everything you learn about electricity and water.
It really does. So the key takeaway from that demonstration is the apparent complete absence of a dangerous electrical current, where you'd absolutely expect one, lethally so.
All right, let's try to unpack this. How on earth did Gray supposedly achieve this? Did Hackenberger, the VP, ever try to explain it?
Hackenberger did later offer a sort of explanation for Gray's EMA motor, the electric magnetic association motor. His theory was that it used extremely short, sharp bursts of high-voltage energy.
High-voltage pulses.
Yes, delivered through a pretty unique electrical circuit design. And critically, it seemed to incorporate some kind of feedback loop, or a recycle or regeneration system that would send pulses back to recharge the initial battery.
So like a super efficient energy recycling setup using these high-voltage spikes.
That's the gist of Hackenberger's explanation. Think of it less as creating energy from nothing, perhaps, and more as an incredibly efficient way of using and reusing it, pulsed high-voltage energy being key.
Okay, so focusing on efficiency. But what about Gray himself? What did he say inspired these ideas? Where did cold electricity come from in his mind?
Gray mentioned a few different things. He recalled getting a really strong shock from a capacitor once, which stuck with him.
Ouch. Okay.
He also talked about observing early government radar tests across the Potomac River, noticing the principle of pulse out, pulse back, sending a signal and analyzing its reflection.
Right, like sonar or radar works.
Exactly. And he apparently had a lifelong fascination with lightning. He observed that lightning seemed more powerful closer to the ground, which made him suspect the air itself played an active role, not just being an insulator.
Interesting connection.
He claimed he combined these observations with what he mysteriously called a super-secret means of generating and mixing static electricity. That mix led to his EMS motor principles, really focusing on harnessing static electricity somehow.
So it sounds like his insights were a blend of accidental discoveries, like the capacitor shock, observations of nature like lightning, and maybe some existing tech like radar.
That seems to be the picture, yes. A combination of factors leading him down this unconventional path.
Right.
Maybe static electricity amplified or manipulated in a novel way.
Like static electricity on steroids, almost. But his story didn't stay focused on just the science, did it? There were some serious legal issues.
Unfortunately, yeah. Things took a pretty dark turn for him. In 1974, the Los Angeles District Attorney's Office actually raided his offices.
A raid? Why?
They confiscated business records and, crucially, his working prototypes. They apparently spent 8 months investigating, trying to find stockholders who felt defrauded and would press charges, but reportedly none did.
So no charges from investors?
Not initially. Eventually, though, Gray did face grand theft charges, but those were ultimately dropped. He later pleaded guilty in 1976 to some relatively minor SEC violations, paid a fine, and was released.
Okay, so some legal trouble, but resolved relatively minorly in the end.
In terms of the sentence, yes. But the really significant and kind of tragic part for his research is that his confiscated prototypes were apparently never returned to him.
Never returned. Wow, that's huge. Your working models, potentially proof of concept, just gone.
Exactly. It leaves this big question mark hanging over the whole affair. What exactly did those prototypes show? Why weren't they returned? It certainly cast a long shadow over his work. The key takeaway is really the unresolved mystery surrounding his tech and the impact of these legal hurdles.
A massive setback, no doubt. Did he manage to continue his research at all after that, or did the raid and the legal battles basically shut him down?
Well, according to the available information, things did go quiet for a while after the legal issues. You can imagine it would be difficult to regroup after something like that. But then, somewhat surprisingly, in the mid-1980s, Gray was actually granted 2 U.S. patents.
Patents, after all that controversy.
Yes. One was for an efficient power supply suitable for inductive loads. That was issued in June 1986. And then another one, about 10 months later, in April 1987, for an efficient electrical conversion switching tube suitable for inductive loads.
Huh. So the patent office, at least, saw something novel or unique in his designs, despite the earlier trouble.
It certainly seems that way. The granting of patents suggests they recognized some inventive step, some unique aspect to his technology, at least on paper.
Interesting. So these patents must offer some pretty crucial clues about how his technology might have actually worked, right? What did they reveal?
They definitely do. And the 2 patents are very closely linked. There's a lot of overlap in the descriptions and diagrams. They essentially detail a system designed to harness what's described as electrostatic or impulse energy.
Impulse energy, again, like those short bursts.
Exactly. Generated by a high-intensity spark discharge with an especially built conversion tube. This tube wasn't simple. It had a low-voltage anode, a high-voltage anode, and 1 or more charge-receiving grids inside.
Receiving grids.
Yeah, and the patents specifically emphasized that the size and the precise positioning of these grids were critical to how much energy you could expect to get out during operation.
Okay, so the core idea in the patents is generating energy from this intense spark and then capturing it somehow with these grids.
That's the fundamental concept presented, yes.
Yeah.
Generating and capturing energy from a high-intensity spark discharge.
A really intense spark. That suggests a very sudden, very powerful release of energy, doesn't it? Not a smooth flow.
Absolutely. Abrupt and powerful. And what makes it even more intriguing is the specific mention of safety components within Gray's circuit diagrams in the patents.
Safety components, like what?
There was a spark gap protection device and also bypass diodes, their stated purpose, to divert and dissipate excess energy if the electrical potentials inside the circuit went above certain limits.
Wait, hang on. Excess energy? That's a very specific and suggestive term to use in a patent.
Isn't it just? It strongly implies that the system wasn't just efficient, but might actually have been producing significantly more energy than was initially put into it to create the spark.
So the need for components specifically designed to dump or get rid of extra energy suggests he anticipated, or maybe even achieved, an output greater than the input.
That's certainly the logical conclusion one draws from the inclusion of those components in that terminology. It's a major point that seems to fly in the face of conventional energy conservation ideas. The deliberate design to handle excess energy is a huge clue.
It really makes you wonder about the fundamental nature of this energy he was claiming to work with. Did his background offer any more clues? We mentioned his fascination with radar and lightning.
Yeah.
Anything else?
He definitely seems to have had a deep and long-standing interest in electronics. Even as a kid, apparently, he was captivated by early radar demonstrations he saw. And get this, he actually joined the Army when he was only 15. He even attended their advanced engineering school for a bit before they found out he was underage and discharged him.
15. Wow.
Yeah. He later served properly in the Navy during World War II. After the war, he worked as a mechanic, but apparently continued studying electromagnetics on his own time. It suggests this lifelong commitment, this drive to understand and experiment with electrical phenomena.
So, a real hands-on guy, combining practical skills with this persistent curiosity about deeper electrical principles. It does paint a clearer picture.
Definitely. Not just a theorist, but someone building and tinkering based on observation and perhaps intuition.
Okay, so that's Gray. Now let's pivot to the other giant in this area, Nikola Tesla. His work, especially in the late 1880s, led him to discover something he called radiant energy. How does that connect to Gray's cold electricity? Are we talking about the same thing?
This is where it gets really fascinating and potentially unifying. Some in-depth analysis, particularly work done by Jerry Vassilatos, strongly suggests there's a fundamental link here.
A link between Tesla's radiant energy and Gray's cold electricity.
Yes. When you carefully compare their experimental setups, the conditions they created, and the effects they reported, well, the similarities are striking. It leads to this really intriguing conclusion that Gray's cold electricity and Tesla's radiant energy are very likely descriptions of the same underlying phenomenon.
Wow.
Just maybe observed and harnessed through slightly different technical approaches. The potential identity of these two seemingly distinct forms of energy is a key takeaway.
Okay, that's a pretty bold claim. So what were some of Tesla's key observations? What led him to this idea of radiant energy? Was there a specific aha moment for him?
There were several, but one really pivotal moment seems to have been an accidental observation he made. He was experimenting with generating electromagnetic waves, as he famously did.
Right.
He was using a powerful bank of capacitors, charged up to extremely high voltages, and then discharging them very abruptly through short, thick copper bars.
Okay, big sudden discharge.
And the resulting explosive bursts produced electrical phenomena unlike anything he'd seen before. Far more powerful, far more dramatic. He knew immediately this unexpected display held some kind of secret he needed to understand.
So a surprisingly intense energy release from what was essentially just a capacitor bank discharge. That was the trigger.
That seems to have been a major catalyst, yes, this anomalous, intense burst.
What was so different about these bursts compared to, say, regular sparks or arcs?
Well, related to this, Tesla also noticed something he called a supercharging effect. This happened with high-voltage DC systems and dynamos, especially in the early days of electrical engineering.
Supercharging effect.
Yeah. Right at the precise instant the power switch was thrown, there would be these instantaneous voltage surges spikes that were many, many times greater than the actual voltage of the power source itself.
Whoa.
It was actually a huge problem back then, a dangerous, troublesome issue for engineers. They spent years trying to figure out how to suppress these unexpected, potentially equipment-destroying or lethal surges with various safety devices.
So this wasn't a smooth ramp-up of power, but this massive, instantaneous jolt that seemed to come out of nowhere.
Exactly. A magnified voltage spike that seemed to defy the expected output of the system. That was another clue for Tesla.
Okay, that's really interesting. And he deliberately experimented with these kinds of discharges too, right? Not just accidental observations.
Oh, absolutely. He started creating what he called impulse discharges, deliberately making these very short, very powerful bursts of electrical energy. And that's when things got even weirder.
How so?
These impulses created penetrating shock waves that he could feel throughout his lab. He described it as a sharp pressure sensation, a tingling, even when he was behind barriers like glass plates or copper shields.
You could feel it through shields.
Yes, which immediately suggested some form of energy transfer or communication that wasn't following conventional electrical pathways, wasn't being stopped by standard shielding. He gave this unusual effect a name: radiant electricity.
Radiant electricity, penetrating materials in a way that normal electricity just doesn't.
Yeah.
That's a crucial distinction.
Absolutely crucial distinction. It hints at something fundamentally different in its nature.
You know, it makes me think, weren't there earlier hints of similar strange effects? People like Joseph Henry or Elihu Thomson, did their observations line up with this?
That's a great point, and yes, there were historical precursors. Joseph Henry, way back in 1842, reported magnetizing steel needles that were stored in a cellar vault.
Magnetizing them from where?
From the spark discharge of a Leyden jar happening on an upper floor of the building. The needles were seemingly shielded by thick brick walls and iron flooring. Henry himself speculated about light-like rays being responsible.
Wow, 1842.
And then Elihu Thomson, in 1872, described getting unexpected sizzling shocks and seeing long sparks jump around his lab, even through walls, while he was experimenting with a big Ruhmkorff induction coil connected to a water pipe and a metal tabletop.
So these earlier accounts, they sort of foreshadowed Tesla's findings, suggesting others had stumbled upon these weird, penetrating electrical effects, too.
Precisely. It suggests Tesla wasn't just imagining things. He was perhaps systematically investigating phenomena that others had encountered fleetingly and maybe couldn't explain or reproduce reliably. Tesla seemed determined to nail it down.
It seems like his lecture in 1892, the one titled Dissipation of Electricity, was a really important moment for him in focusing on this. Why was that lecture so significant?
It was definitely a turning point, because in that lecture, Tesla very deliberately shifted focus. He moved away from discussing the alternating currents that had made him famous and started concentrating specifically on the effects of these very sharp electrical impulses.
Okay, a public shift in focus.
Yes, he described the physical sensations those shockwaves he felt. But he also detailed observing strange, almost gaseous streams emanating from wires that were submerged in oil and then hit with these abrupt high-voltage charges.
Gaseous streams from a wire in oil.
Yeah. At first, he thought maybe it was just dissolved gases being released from the wire's surface, but he realized the effect could be sustained for way too long for that simple explanation. These streams were persistent, even creating visible depressions on the surface of the oil.
That's bizarre. So that lecture marked his intentional turn towards studying these impulse effects and these weird associated phenomena like the streams.
Exactly. It was a clear signal of his new research direction, moving beyond conventional AC.
He initially called these phenomena sound waves of electrified air, I read somewhere. But then he seemed to realize it wasn't just air, that some other medium had to be involved.
Right. That was an early interpretation. But as he experimented more, he recognized that, quote, besides the air, another medium is present. He started to believe that his impulse-generating apparatus wasn't just pulsing electricity. It was fundamentally modifying the dynamo's field, extending its powerful electrical energies out into space in this new form, radiant electricity.
Modifying the field itself.
That was his thinking. He theorized he'd stumbled upon a previously unrecognized electrical force. He described it using terms like electrodynamic or sometimes more electrostatic in nature, but possessing much greater intensity and this uncanny ability to penetrate materials compared to ordinary electrostatic fields.
So he was convinced it wasn't just pulsed conventional electricity, it had fundamentally different properties, a new kind of electrical force.
Precisely. He wasn't just chopping up regular electricity. He believed he was accessing or generating something distinct. He figured out how to produce rapid sequences of these impulses. Crucially, unidirectional impulses always flowing in one direction.
Unidirectional, not alternating back and forth.
Correct. And these rapid unidirectional pulses could, as he demonstrated, permeate large volumes of space and pass through shields with relative ease. He immediately saw the potential for wireless power transmission.
Of course.
He described this radiant electricity as involving longitudinal waves.
Longitudinal, like sound waves. Different from standard transverse electromagnetic waves like light or radio.
It's exactly like sound waves, in terms of the direction of oscillation relative to propagation. He saw them as successive shocking waves capable of directly pushing electrical charges along in their path, not the sideways wiggle of transverse EM waves.
That's a fundamental difference in wave mechanics. And what kind of effects did he observe with this radiant energy? Were they as strange as their way it propagated?
Oh, the effects were quite remarkable and varied. Objects placed near his apparatus would become powerfully electrified, often holding on to a single type of charge, positive or negative, for a long time.
Just by being nearby.
Yes. He could even project this charge onto objects or draw charge away from them using a specially designed asymmetrical magnetic discharger he invented. And the physiological effects were fascinating too. Depending on the duration of the impulses, how long each pulse lasted, observers reported wildly different sensations. sometimes nothing at all, sometimes intense heat, sometimes seeing flashes of light, and sometimes even feeling cool breezes emanating from the equipment.
Cool breezes from an electrical device.
Apparently so.
Yeah.
And crucially, he stated that none of these varied effects could be duplicated using high-frequency alternating currents, only with these sharp, unidirectional impulses.
So the impulse nature was key to these specific effects. What about that experiment with the copper helix coil in the shock zone? That sounds particularly strange.
Ah, yes, that one really defies conventional explanation. He placed a thin-walled copper tube, wound like a coil, into this region near his discharger that he called the shock zone. The coil became enveloped in brilliant white sparks, but not just sparks. Long, fluid-like, silvery white streamers erupted from its surface, flowing sort of perpendicular to the windings of the coil, as like the shock wave clung to the coil's surface and flowed over it in this weird way.
Streamers, not just sparks.
Right. And the length of these discharges was apparently incredible, far, far longer than any conventional electrical theory would predict based on the voltages involved. He described it as an electrostatic action, but the discharge lengths were incomprehensible by standard rules.
Incomprehensible discharge length. And didn't this observation lead him to formulate different laws of induction and even coin the term transformer in a new context?
Yes, precisely.
Yeah.
In these specific radiant energy experiments, Tesla reported measuring conditions where there was virtually zero current flowing in the secondary coil of his apparatus.
Zero current, but voltage.
Exactly. Pure voltage seemed to rise along the length of the secondary coil without the accompanying current flow you'd expect in normal electromagnetic induction. This observation led him to develop what he called his electrostatic induction laws, which he saw as distinct from the standard laws of magnetoinduction that govern conventional transformers.
So induction without current.
That's what he seemed to be observing in this specific context. And interestingly, he started referring to his whole setup, the disruptive discharge part, plus the secondary helix coil, as a transformer, even though by his own admission, it operated on fundamentally different principles than the devices we now call transformers.
That's fascinating. He also talked about a skin effect that was different, didn't he? Like the pulses behave like gas.
He did. He noted that these high-voltage impulses seemed to travel over the surface of the conductor, behaving more like pulses of gas rushing over the skin of the wire, rather than electrical current soaking through the wire's cross-section as we normally picture it.
Like a fluid dynamic effect on the wire surface.
Sort of, yeah. And another related, really bizarre experiment involved a thick, U-shaped copper bar. He connected incandescent light bulbs across the ends of this U-bar.
Okay.
When he pulsed the bar with his radiant energy, the lamps would light up brightly with a cold white light. But here's the kicker. They stayed lit, even while being essentially short-circuited by the heavy copper bar connecting them.
How is that possible? A short circuit should kill the voltage difference. The lamp should go out.
Exactly. It shouldn't work. Tesla interpreted this as suggesting a kind of separation or fractionation of what we normally consider a single electrical current. He speculated maybe it was splitting into different components, perhaps an electronic current and some kind of neutral or etheric current that behave differently.
Splitting the current. It's like he felt he was peeling back layers of reality looking inside electricity itself.
That's a good way to put it. He came to the conclusion that ordinary electrical discharges weren't monolithic. He thought they actually contained several different types of mobile species or energetic components.
These components were only revealed by
these abrupt, unidirectional impulses. His earlier work with smooth, alternating currents hadn't shown these effects. This realization really pushed him further into thinking about the fundamental medium of space itself, the concept of the ether.
Ah, the ether. Such a historically contentious idea. What was Tesla's take on it, and how did it fit with radiant energy?
Tesla became a firm believer in the ether. He came to think that dielectric fields, the fields associated with voltage or electrical potential, weren't just abstract mathematical constructs. He believed they were actual physical streams within this universal, all-pervading ether medium.
So voltage was like ether pressure.
Kind of, yeah. He theorized that if you could figure out how to effectively tap into and conduct these naturally occurring dielectric field lines, these ether streams, you could potentially access a limitless source of energy directly from the environment.
Limitless energy from the ether. That's the ultimate free energy concept, isn't it?
It is. And he seemed to get tantalizingly close, in his view. He reported producing these amazing, cool, misty white streamers that would extend a yard, maybe more, into space from his rapid impulse devices.
Cool and misty white, not like hot, angry sparks.
Exactly. And despite potentially involving millions of volts, these streamers were reported to be harmless to the touch. You could apparently put your hand right in them without harm, completely unlike typical high-voltage discharges, which are instantly lethal.
Harmless millions of volts. Okay, that just fundamentally breaks our standard understanding of electrical danger and behavior.
It absolutely does. And Tesla was adamant about this. His radiant energy technologies, he claimed, did not rely on electrons moving through wires as the primary working fluid, like conventional electricity does.
So if not electrons, then what?
He talked about light-like rays and the direct manipulation of the natural medium, the ether. He observed that these etheric streams, when put under the high pressure generated by his impulse devices, could apparently even penetrate solid materials. He described hearing a hissing sound as they did, suggesting a normally suppressed or hidden current being released by the impulsive discharge.
Hissing sounds from penetrating energy.
Yeah. He also experimented with specially shaped cone-like coils. He believed these could help focus what he called the gas dynamic component of this radiant energy. He came to understand that the visible, flame-like discharges, the bright sparks and arcs, actually represented lost power, energy that wasn't being effectively broadcast or utilized in its radiant form.
So the quiet, invisible transmission was the goal. The flashy stuff was waste.
That seems to be the idea. Efficiency meant minimizing the visible discharge and maximizing the radiant effect.
And his ultimate vision of what this radiant energy was, it was pretty radical, wasn't it?
Yeah.
Massless. Faster than light.
Oh, completely radical. He ultimately conceived of radiant matter as being virtually massless, hydrodynamically incompressible, like a perfect fluid whose density couldn't be changed by pressure and propagating instantaneously, or at least at speeds far exceeding the speed of light. Superluminal velocity.
Wow.
In essence, he viewed it as pure energy, existing in this unique, unlocked form. And he concluded that his entire technological approach, the core of his most advanced work, was fundamentally impulse technology. Generating true radiant energy absolutely required these succinct, incredibly brief, powerful impulses created by disruptive electrical discharge. No impulses, no radiant energy.
Tesla technology is impulse technology. That's a powerful summary. So let's tie this back together. We have Tesla's radiant energy, born from impulse discharges. We have Gray's cold electricity, also seemingly from impulse discharges, possibly producing excess energy. The central idea you mentioned is that they're likely the same thing.
That's the strong suggestion, yes.
How can we nail down that connection more firmly? Is there a specific mechanism or event that links them?
There is. It's been termed the Electro-Radiant event. This concept acts as a kind of unifying principle that seems to encompass the observations of both Tesla and Gray.
The Electro-Radiant event. Okay, what defines it? How is it produced?
Based on analysis of their work, it seems to be produced specifically by the extremely abrupt interruption of a high-voltage direct current across a spark gap. And critically, this interruption has to happen before any significant back-and-forth oscillation or current reversal can occur in the spark. It needs to be a sharp, one-way break.
A very fast, clean break in high-voltage DC. Okay. And what are the key characteristics, the signature features of this electro-radiant event once it's generated?
There are several defining characteristics that emerge from their descriptions. First, the energy seems to leave the conducting wires perpendicularly to their surface, not just flowing along them.
Okay, radiating outwards.
Second, it generates a voltage effect that is spatially distributed, spread out in the space around the discharge, and this voltage is significantly higher than the voltage that initiated the spark in the first place.
Higher voltage appearing seemingly from nowhere.
That's how it appears. Third, it propagates almost instantaneously, behaving like a longitudinal electrostatic light-like ray. Some descriptions compare its behavior to an incompressible gas.
Longitudinal, like we discussed with Tesla.
Yep.
And instantaneous.
Wow. Wow. Fourth, the event itself is characterized by its extremely short duration, the impulse time and the voltage drop across the spark gap during that instant. Fifth, it has this ability to penetrate various materials, shield that would normally block electrical effects. The penetrating effect again.
Yes, and when it interacts with metals, particularly copper, it induces what are described as electronic responses within the metal. And finally, the whole effect is significantly magnified or enhanced if you use a charged capacitor as the source for that initial high-voltage DC discharge, compared to just using a steady DC source.
Okay, so that list of characteristics, perpendicular emission, voltage multiplication, longitudinal instantaneous propagation, penetration, interaction with metals, enhancement by capacitors, that really seems to tick boxes for both Tesla's descriptions and what Gray was likely doing with his spark gap capacitor setup.
Exactly. It fits remarkably well. Tesla's disruptive discharge apparatus, Gray's high-voltage capacitor discharge across his switching tube spark gap, both seem designed, perhaps intuitively in Gray's case, to create precisely these conditions for the Electro-Radiant event.
So when you look at Gray's patents again, through this lens of the Electro-Radiant event derived largely from Tesla's work, the confusing parts maybe start to make more sense. They really do. Analyzing the often cryptic clues and diagrams in Gray's patents, alongside the detailed research on Tesla, like Vassilatos' work, illuminates that connection. Gray's circuit schematics are notoriously difficult to make sense of using just conventional electrical theory. They seem incomplete or contradictory.
Right.
But when you overlay the principles of the Electro-Radiant event, the components in their arrangement start to look purposeful, even if Gray himself couldn't fully articulate the underlying physics in his patent text.
Let's go back to Gray's efficient power supply patent. You mentioned the safety components, the spark gap protector, the bypass diodes for excess energy. How do those fit the Electro-Radiant event picture?
They fit perfectly. Their very presence strongly suggests Gray was generating anomalous energy via the Electro-Radiant event energy beyond the input, energy that needed managing. It's evidence he was dealing with the voltage multiplication aspect.
Okay. What about the timing elements? The commutator and the high-speed switching tube?
Those seem absolutely crucial for creating the event. They appear designed to precisely time the capacitor discharge, ensuring that incredibly rapid, clean break, that one-way energy path across the spark gap, which is consistent with Tesla's conditions for maximizing radiant effects. They controlled the impulse.
Got it. And the inductive load, you said its function was a bit ambiguous in the patent. How might it fit in?
Right, the patent mentions maybe using it for mechanical work via repelling coils. But in the Electro-Radiant framework, it seems more likely that the inductive load serves as the point where the harnessed energy was extracted.
Extracted after what?
After the Electro-Radiant energy, generated at the spark gap, was intercepted by those charge-receiving grids in the conversion tube and then somehow converted back into a more conventional electrical form that could power a device or, crucially, recharge a battery. The load is where the output was taken.
Okay, so the conversion tube with those grids sounds absolutely central. Tell me more about that. How did it likely work with the Electro-Radiant event?
It really does seem to be the heart of Gray's system. That conversion element switching tube, figure 29 in one patent, had the resistor, the spark gap, rated around 3,000 volts apparently, and those critical charge receiving grids.
Right.
The high-voltage anode within that tube, fed by the capacitor discharge, likely served as the point source, the emitter, projecting the Electro-Radiant energy outwards.
And the grids caught it.
That's the idea. Those concentric grids, strategically placed, were designed to intercept this outward radiating energy burst. And, based on photos of Gray's actual devices, those grids were very likely made of copper.
Copper again. Which is interesting because you mentioned Tesla sometimes found copper problematic, causing electronic contamination in his larger systems. Why would Gray use it for receiving?
That's a really sharp observation. It's possible that while Tesla, aiming for long-range wireless transmission, wanted to avoid converting the radiant energy back into conventional electricity prematurely, which copper seemed to do, Gray's goal was different.
Gray wanted to capture it locally.
Exactly. In Gray's relatively compact system, designed to charge a battery or run a load right there, copper's natural tendency to readily produce these electronic responses when hit by radiant energy might have been precisely why he used it. It could have been the ideal material to facilitate the conversion back into a usable form of electricity to charge his secondary battery.
So copper acted as the transducer, intercepting the radiant energy and turning it back into something that could charge a battery. Makes sense in that context?
It seems plausible. It fits the evidence, like those photos showing Gray's benchtop setups with multiple conversion tubes being fed by big, chunky, high-voltage capacitors, 4,000 volts, 2 microfarads apparently. Serious energy storage for creating those impulses.
And you mentioned an air core transformer might have been involved too.
Yes, likely used to inductively couple the pulsed energy coming out of the conversion tube's collection system to power other parts of the circuit, maybe those popping magnets he used in some demonstrations, or to step down the voltage current for battery charging.
Okay, so if you had to draw a simplified schematic of how Gray's cold electricity circuit probably worked, based on this electroradiant interpretation, what would the key stages be?
You'd have 1. A primary battery. 2. This battery charges a capacitor to high voltage. 3. A high-speed switch triggers the capacitor to discharge abruptly through 4. The conversion switching tube specifically across its spark gap. 5. This creates the electro-radiant event. 6. The charge-receiving grids inside the tube intercept this event. 7. The grids, likely via copper interaction and perhaps an inductive load transformer, convert the captured energy back into usable electricity. 8. This output electricity is then used to recharge a secondary battery or power a load.
And then presumably he had a way to switch, so the secondary battery becomes the primary, charging the capacitor for the next cycle.
Exactly. That switching mechanism would allow for potentially continuous operation, with the system recharging its own power source, plus potentially providing excess energy. That seems to be the inferred operating principle.
But as we touched on, Gray's own explanation in the patent, his theory about mixing low and high voltage, that doesn't actually explain this electro-radiant process at all, does it?
Not even remotely. His stated theory about creating a power gain by somehow combining low voltage current and high voltage is, frankly, inconsistent with established physics and wouldn't produce the specific cold electricity effects reported, like the bulb in water. Plus, the resistors shown in his diagrams would actively limit conventional current flow, working against his own explanation.
So why include that flawed theory?
It's hard to say for sure. Maybe he didn't fully understand the deep physics himself, even if he could build working devices through intuition and experiment. Or, perhaps more cynically, maybe he intentionally obscured the true mechanism with a plausible-sounding but incorrect theory to satisfy patent examiners while protecting the real secret, the harnessing of the electro-radiant event.
The real secret being rooted in Tesla's discoveries about impulse discharges.
That seems the most likely scenario, given the alignment between Tesla's detailed radiant energy work and the reconstructed function of Gray's device based on the patents and demonstrations. The energy gain wasn't from mixing currents. It was likely from tapping this radiant energy released by the spark.
Which brings us right back to the core challenge here, doesn't it? If these phenomena graze excess energy, Tesla's radiant effects are genuine, they seem to smash right into the foundational laws of thermodynamics.
They certainly appear to, yes. Particularly the first law, the conservation of energy, stating energy can't be created or destroyed, only change forms. And the second law, concerning the inevitable increase of entropy or disorder in closed systems. Both seem challenged by the apparent energy gains and the unusual energy transformations reported.
These laws, established by giants like Hermann von Helmholtz and Rudolf Clausius based on meticulous studies of heat and mechanical work, are cornerstones of modern physics. They led directly to the conclusion that energy is always conserved and that perpetual motion machines are impossible.
Absolutely. Their work was fundamental and incredibly powerful within the scope of the systems they studied, mainly heat engines and macroscopic mechanics. However, the alternative science viewpoint, looking at Tesla and Gray, suggests that perhaps the intellectual overlay, the theoretical framework built upon those initial experiments, might have inadvertently introduced limitations.
Limitations in how we define energy conversion, maybe, or the nature of heat itself.
Potentially, yes.
Yeah.
And the second law, specifically its application to closed systems, is often questioned. Is the universe truly a closed system in the thermodynamic sense? Could energy concentrations increase locally and spontaneously under certain conditions, drawing from a background field? Some researchers point to phenomena like certain weather engineering experiments and examples where order seems to increase locally, seemingly defying simple entropy increase.
This echoes the idea of that background etheric energy field you mentioned earlier, a potential source for this free energy.
Exactly. It posits this fundamental, ubiquitous energy field, called ether, zero-point energy, orgone, whatever term you prefer, that isn't accounted for in standard thermodynamics, but might be accessible. The idea is that it can be accumulated, perhaps without doing conventional work, and then released in controlled ways.
And proponents would say Tesla and Gray were tapping into this field.
That's the argument, that they stumbled upon methods primarily involving these sharp electrical impulses to interact with and draw energy from this underlying field. People sometimes cite Wilhelm Reich's claims of lighting bulbs and running motors with energy collected by his orgone accumulators as related phenomena. The suggestion is that this ethericity might behave very differently from conventional electricity, maybe even powering things on the charging or accumulation phase, not just discharge.
Which would fundamentally challenge the first law's concepts of energy conversion and conservation, wouldn't it? If you're getting apparent energy transmutation or localized increases in energy without a clear conventional input.
Precisely. It questions the very definitions. Some alternative thinkers, like Rudolf Steiner, even propose that heat might not be merely molecular motion, as conventionally understood, but perhaps a more fundamental state of matter, or even a transition state between matter and this etheric realm.
That's a deep philosophical shift as well as a physical one.
It is. And the conclusion often drawn from this line of thinking is that we need to let experimental science lead the way again, to investigate these anomalous phenomena with genuinely open minds, without being completely bound by the theoretical limitations inherited from 19th century thermodynamics, and potentially rediscover or unlock the principles of what some call etheric science.
It's definitely a perspective that opens up a whole universe of possibilities and challenges some very deeply ingrained scientific assumptions. So as you can hear, this deep dive into the work of Tesla and Gray, well, it unveils some truly fascinating, potentially paradigm-shifting questions about the real nature of energy and maybe the limitations of our current scientific grasp on it.
Absolutely. The ideas of cold electricity, radiant energy, even if they remain on the fringes of mainstream acceptance, they present this compelling, persistent puzzle. They hint at technological pathways that, if they could be reliably navigated, could be utterly revolutionary.
We really encourage you, the listener, to mull over these concepts. Maybe dig a bit deeper into the historical accounts, the patents, the analyses we've touched on. Consider the profound implications if these phenomena are real and could be harnessed.
What parts of this resonate most strongly with you? What further questions does it spark about the energy that powers our world, and maybe the energy that lies unseen all around us?
It really highlights the importance of keeping an open mind, doesn't it? While still demanding rigorous investigation, of course. But acknowledging that our current models, however successful, might not be the final word.
Definitely. There could still be vast territories of energy science waiting to be explored.
Thanks for listening to this deep dive into the cabinet of science and fiction.
Until next episode.